This rock is smaller, but it looks like the same type of rock as this mountain.
Weathering happens over time. It's a process. Weathering can break large rocks into small rocks. Weathering breaks smaller rocks down further into soil, sand, or even tiny particles called sediment. But what causes weathering? Water, ice, wind, plants, heating and cooling. All of these things affect the earth and play a part in breaking rocks down into smaller pieces. They are the causes or agents of weathering. Water. Some of these agents can cause change physically. That is, just by the force of contacting the rock. Water, in all its forms, is the most powerful agent. The physical force of water and ice can break rocks and wear away their surfaces. When water freezes in cracks in rocks, it expands. It gets bigger. The force of expanding water is so great, it can actually split rock apart. You might have discovered this yourself if you've ever frozen a water bottle to take to school. That bottle is full of water, all the way to the top. It's standing nicely in the freezer. You think, I can put it on my desk tomorrow and let it melt. I'll have cold water all day long. The next morning, though, what's happened? The bottle won't stand up. The frozen water has gotten bigger. It has expanded and pushed out the bottom of the bottle. It's no longer flat. The freezing action of water can expand the cracks in rocks and break them up. The flowing action of water can weather rock too. It slowly wears the surface of rocks away. This stream bottom has been worn smooth. And when water flows over rocks, it not only causes a physical change, it can cause a change inside the rock to the different materials that make up the rock. This is called a chemical change. Let's see what water with a little vinegar, a weak acid from plants, can do to this soft rock called soapstone. After just a few minutes, you can begin to see particles in the water. Let's wait just a little longer. Now look, parts of this soft rock have dissolved. Why did some of the rock wash away here and some of it stay there? Water caused a chemical change. It was able to dissolve some of the material in the rock, while other parts did not dissolve. We saw how water can get into cracks in rocks, freeze, expand, and break rocks down. The same thing can happen with plants. Plants. Plants can grow in cracks in rocks. As the plant grows, the roots of the plant grow too, making the crack bigger and bigger until wind. This landform in Utah may have been smooth at one time. Desert winds carrying sand have weathered this surface. These workmen are getting ready to paint this truck. They're using this machine that blows air and sand to blast away the old paint. It's called a sandblaster. Look what sand and wind can do to a soft surface like wood in just a few minutes. Just like that sandblaster, over time, wind can weather away the surface of landforms, changing the way they look. Temperature. The wind isn't blowing on this rock in the sun, but this rock is still weathering. It's getting warmer now, and some of the materials in the rock are expanding quickly with the heat. Other materials in the same rock are expanding slowly. When the sun goes down, they'll contract or get smaller at different speeds too. This expansion and contraction is all smaller than we can see with our own eyes, but over time, it is enough to slowly break the rock down.
Let's review weathering. Our Unit 1 test will be November 2nd. So weathering is the process where rocks are broken down either by gravity, air, or water. Different things can break up rocks, and that's why there are two types of weathering. There is physical weathering and chemical weathering. They are the same because they both break down the rocks. However, they are different because physical weathering breaks down the rocks, but the material that it is made of, it stays the same. Chemical weathering affects the rocks by different chemicals in the environment that can make the rocks weak and begins to change the material that rocks are made up of. So let's start with physical weathering. When rocks fall or slide off cliffs, the impact of them falling, it makes the rocks break into smaller pieces. Think about it like a teacup or a glass. When you have a teacup and you drop it on the floor, it shatters into many pieces. Now, is the teacup, what it's made up, still the same? Yeah, but is it the same shape or size as the original teacup? No, it has broken down to smaller pieces, and that's kind of how physical weathering works. So the minerals stay the same as the big rocks, it's just the size that is breaking down. Physical weathering can break up the rocks through many different forms. One of them is through the temperature, either hot or cold. For example, waters can get in between the cracks of the rock, and when the water is inside the rocks, the water begins to freeze. When water freezes, it goes from being a liquid to a solid, and when it becomes that solid, it begins to expand or become wider. And when it becomes wider and it takes up more space, the rocks can burst and become smaller pieces. Also, in desert or mountains, the weather changes very quickly. For example, during the day, it can be very cold. During the day, it can be very hot. However, at nighttime, it becomes very cold. So that change of weather happening quickly, it can change what the rock is made of. Another example is the roots of a tree or trees growing in between rocks. When those roots of a tree begin to grow inside rocks, it needs space. So it is going to stretch out the rocks, and when it's stretching out those rocks so it can have space to grow, the rocks will begin to break apart. There are many different ways that physical weathering can occur. When rocks bang, rub, or grind against each other, they become too worn down and they begin to break. So another example of weathering that we talked about is chemical weathering. Chemical weathering is different than physical weathering. The minerals in the rocks can change by chemicals that are found in water or air. For example, one of the minerals that are in rocks is iron. One chemical that is in the air that we breathe is oxygen. When oxygen and the iron come together, it causes the rocks to begin to rust. Rust is like this orangey material that kind of makes the rocks weak. When the rocks become weaker, it is much easier for them to break apart. So the rocks aren't necessarily becoming smaller. It's just that the material that is in the rock is changing, and when that material changes, the rocks begin to break. Another example is carbon dioxide, which is a type of gas. Carbon dioxide, it can dissolve in water. And when carbon dioxide comes in contact with water, it becomes an acid, which is another example of a chemical. When this chemical acid becomes in contact with the rocks, it begins to make holes in the different types of rocks. I don't know if you've seen a statue or, for example, the Rocky statue at the art museum. It's a very old statue, and when we have rainy days, that rainwater definitely has acid. And if you take a close look at it, you will notice that there are holes in this statue. That is because the water has become weak. The statue has become weak, and it is changing what the rock is made up of, and the minerals are changing in the rock. Another example of how chemical weathering occurs is when salt, which not salt that can be found in your kitchen. Salt that exists in our environment. Sodium. It's very so when this soft material mixes with the minerals that are rocks, it makes the minerals in the it makes the minerals in the rock become new material. And that is because when you mix a hard material like the minerals in rocks with the salt, which is softer, it causes a reaction between the minerals. And this reaction, again, it creates holes in the rocks. These holes end up making the rocks weak and they break apart. So chemical weathering, it is the process when rocks are broken down because they're becoming weaker and the minerals that make up the rock is what changes. Now let's look at some examples. Look at this rock that is right here. So acid rain has fallen on this stone over many years and it has caused it to break down. See how the rock has different shapes throughout the rocks? Throughout the different rocks, you see how there's like this curve right here, or at some places kind of bumpy. What do you think? Was this because of physical weathering or chemical weathering? Let's look at another example. So this rock, it seems that it is in, there is water in the middle. It says that sand has been swirling or rubbing around in the water, and when it rubs around, it made the rocks into new shapes. For example, it created this hole. The rocks that are at the bottom have become smaller, just as this. So, do you think that's physical or chemical weathering? Next example. So now we have an example of a tree that is growing in between the rocks. The roots of the tree have begun to grow in rocks, and it is expanding in the cracks and making the cracks much wider, so the tree has enough space to grow. Now, it says the roots of this tree has expanded in the crack of a boulder. Do you think this is physical or chemical weathering? Remember, physical weathering is when the rocks break down and become smaller, and chemical weathering is when minerals become weak and change the material. Last example. Notice how this rock has many different holes. It's also kind of bumpy, and it's orangey, which it makes me think that is rust that has developed through the rock. It says oxygen in the air has reacted with the iron in the rock minerals and created rust. It made the pieces of rock flake and created holes. So what do you think? Is this physical or chemical weathering?